Good morning children. Welcome to our next class. In last class we discussed about physical properties of metals and non-metals, and in periodic table how the metals, non-metals and metalloids are arranged, and only the physical properties are not enough to identify whether the element is metal or non-metal. So today we are going to discuss about their chemical properties which help us to divide the metals and non-metals. So our today's topic is chemical properties of metals and non-metals. Metals and non-metals. Now we'll see how the metals reacts with oxygen. So now we are going to observe that reaction with oxygen. How metals react with oxygen we'll see. When any metal reacts with oxygen, they form their metal oxides. For example, if you take mercury or magnesium you take, when magnesium, symbol of magnesium is Mg, when Mg reacts with O2, oxygen, it releases the magnesium oxide MgO. So when any metal is reacting with oxygen, they form their metal oxides. What they are forming? Metal oxides. Is this metal oxide base or acid? Acidic in nature or base in nature? To identify, you need to do one small activity here. You take this magnesium oxide after reacting with oxygen. What the magnesium oxide is formed, this you take in a watch glass and add few drops of water to this. Magnesium oxide plus water, it completely get mixed in the water. This ash is formed. After the magnesium oxide burnt, the ash is formed. This ash completely dissolve in the water. So this magnesium oxide dissolved water you test with red litmus and blue litmus papers. And when you test with red and blue litmus papers, this red litmus paper will turn into blue color. So this is the indication you learned in class 7 about acid bases and the indicators, natural indicators like phenolphthalein and litmus papers, how we use to identify whether the given object is, whether the given thing is acid or base, you know. So same way, when you test with red litmus, that is turning into blue color. That shows the metal oxides are basic in nature. Metal oxides are base in nature. That you can understand by testing with red litmus paper. When you see the other example of metals, how they react with oxygen, you take iron. In second example, iron symbol is Fe. When it is reacting with O2, it forms FeO, ferrous oxide. Now this ferrous oxide is formed when it is reacting with oxygen. In the same way, you also know that rusting, how rusting is formed, you know very well. When iron reacts with oxygen plus a little amount of water, if it reacts with water and oxygen, then it forms Fe2O3, ferrous oxide along with X amount of water. Any number of water molecules can be here. So this is the formula for rusting. How the rusting is formed. Any iron object, when you leave like that for some days, it will come in contact with the air, and also sometimes some water vapor is present in the air. So that water vapor and the air both will react with the iron and they form the iron oxide, that is nothing but the rust. So take this rust which is formed, it will be brown in color like this. You collect some rust from any rusted particle and you mix this in the water. It will not mix in the water, but only after mixing you take little amount of water from that where the rust is mixed in the water. So that you take and again test with red litmus and the blue litmus papers. And this you can do it in your home. If not, red litmus, blue litmus papers are not available in your home, you can even use your natural indicators like hibiscus leaves or powder you can use by applying on a white paper. Let it dry for some time. That papers you can use as natural indicators. This all you learnt in class 7. So by using that also you can find out this rust part is it acid in nature or basic in nature. Definitely after the experiment when you do, clearly you will understand. You please go through this experiment in your home. So final result will be the red litmus will turn into like blue litmus. So this shows that whenever the metals are reacting with oxygen, they are forming the oxides. Metal oxides are formed and these metal oxides are basic in nature. They shows the base properties. Understood, children? So up to here we have completed how metals are reacting with oxygen. Metals are reacting with oxygen. Now we will see how non-metals react with oxygen. How non-metals are going to react with oxygen, we'll see now. Non-metals also react with oxygen and they form their non-metal oxides. Non-metal oxides they form. When metals reacts with oxygen, they are forming metal oxides. When non-metals reacts with oxygen, they are forming non-metal oxides. We'll see one example. Amount of sulfur. Take small amount of sulfur. Small amount of sulfur you take, and when it reacts with oxygen, it forms the SO2. When it is reacting with oxygen, when sulfur reacts with oxygen, it's forming the SO2. SO2 means sulfur dioxide. Sulfur dioxide is formed when sulfur reacts with oxygen. When this sulfur dioxide, when it reacts with water, you add little amount of water to this, then it forms H2SO3. This is nothing but sulfurous acid. H2SO3 is sulfurous acid. So it shows the base character, the acidic characters. H2SO3 shows the acid characters, acidic in nature. How do we know that? Again the same way, you take litmus papers and test with this H2SO4. Now here the blue litmus paper changes into red color. This is the indication that the given H2SO3 is acidic in nature. So did you understand now? When nonmetals are reacting with oxygen, they are forming their non-metal oxides like SO2. Sulfur is non-metal. when it is reacting with oxygen, it's forming SO2, sulfur dioxide. When sulfur dioxide, if we add little amount of water, it forms the H2SO3. H2SO3 means sulfurous acid. This sulfurous acid, when we test with the litmus paper, the blue litmus paper is turning into like red litmus paper. So this is the indication that non-metal oxides are acidic in nature. And we'll see how the sulfur reacts with the oxygen. You take little amount of sulfur in a deflagrating spoon. Deflagrating spoon will be like this, a bent. So if this deflagrating spoon, you take little amount of sulfur. If this deflagrating spoon is not there, take a cap of any medicine bottle cap you take, and with a wire, iron wire, you tie to this and make it like deflagrating spoon. How to make that given in your NCERT textbook, you can go through that. And after burn the sulfur, then immediately keep this deflagrating spoon inside a glass jar, or inside a glass jar you keep it, and see that the gas which is produced when we burn the sulfur, that gas should not go outside. So immediately you cover the glass jar with a lid, and after some time slowly remove the lid and add little amount of water. So the gas which is formed after burning the sulfur is nothing but sulfur dioxide. So to that sulfur dioxide you are adding the water. When they both react with each other, they are forming the sulfurous acid. This shows the acidic characters. So this is one example how the nonmetals are reacting with oxygen. Now we will see how the metals and nonmetals reacts with water. So now we understood that how metals and nonmetals are reacting. When they form metal oxides, they are metals. When they are forming non-metal oxides, they are non-metals. So these characters, these chemical properties help us a lot to identify the metals and non-metals. Now how they are reacting with water? How they are reacting with water, we'll see now. How the metals and non-metals react with water. You take small piece of sodium. What you are taking? Small piece of sodium. Sodium highly reactive metal. So it vigorously reacts. That's why it is stored inside the kerosene. So you take a little small pellet of sodium and place it on watch glass. Okay, you wrap this in cotton and dip this cotton ball inside the water. So now you are making this sodium to react with water. You can easily see how the sodium is moving inside. Sometimes even it releases some fire also. So you should be very careful when you are doing this experiment. Vigorously it reacts with water and it forms the sodium hydroxide. Sodium hydroxide. One O, one H is over. Still hydrogen gas is released outside and some energy is also released. So when sodium is reacting with water, it's releasing sodium hydroxide plus hydrogen gas. This hydrogen gas is released outside along with some energy and there is a chance to catch the fire. So when metals are reacting with water, they are forming their oxides or else hydroxides. They form their hydroxides. They form their hydroxides or oxides. They form either metal hydroxides or they can also form metal oxides. When they form these metal hydroxides and metal oxides, when they are reacting with water, along with this metal hydroxide and metal oxides, they are also releasing hydrogen gas. Hydrogen gas is released with some energy. So this energy may helpful for this hydrogen to catch the fire. So it's a vigorous reaction. That's why you need to wrap the sodium in any cotton and then release into the water. So how in this way the metals are reacting with water. How sodium reacting with water. How vigorously the reaction went on. So to understand this, you can even after completing the reaction, you can hold that beaker where you dropped this sodium by wrapping in the cotton. You can feel the warmness by holding that beaker. That means it was releasing the energy. So such vigorant reaction with metals and water can't be seen in all other metals. Other metals cannot react in this way with water. Why? Because the metals which are more reactive than hydrogen, the metals which are more reactive than hydrogen, only these metals can react with water. Which are more reactive than hydrogen, they can only react with the water. Right? So some metals, they will never show any reaction with water at all. If you take iron you had seen, it reacts with water very slowly. And just now we discussed about rusting process. How the iron with the water and some amount of moisture in the air plus oxygen reacting and forming the Fe2O3 rust formula we had seen just now. Same way, that means the iron is reacting with water very slowly. If you take copper, Cu, in copper bottom vessels, utensils will be in our homes, copper utensils. So sometimes we can see a green color coating on that copper bottom utensils. Why? Because this copper is also reacting slowly, not immediately formed. Copper utensils, if you keep outside, immediately they are not getting the green color coating. They take some time. That means they are reacting slowly with H2O and oxygen and plus CO2 which is present in the air. That means they are coming in contact with air. Then they form copper hydroxide, CuOH twice. Copper hydroxides are formed. Even when metals react with oxygen, they form their hydroxides. Just now we discussed reaction with oxygen. When we discussed, we did that same way. They are even reacting with the water, but slowly they are reacting with the water. Even they are reacting with the oxygen, they are forming their oxides, metal oxides. This is also one of the example, copper hydroxide. Copper oxide is formed. So silver and gold when you take, they will not react with water at all. If such reactions take place, we couldn't wear our ornaments at all, right? So there is no reaction with some metals when they are coming in contact with water. But when they are reacting, why sodium is very highly reacting, vigorous reaction showing means the sodium reactivity is more than hydrogen. That's why it's vigorously reacting with water. Now, next class we'll discuss about the reactive series of metals whose reaction capacity is more, which metal will be more, and then which metal. That series we'll discuss tomorrow. And if we come to the non-metals, how the non-metals are reacting with water, we'll see now. Till now we discussed about metals. Now we'll see how the non-metals are reacting with water. Non-metal plus water, how they react. They will never react with water at all. They won't show any reaction, no reaction when non-metals are mixing with water. And you know, every time some exceptions will be, even though they are not reacting with water, when they react with oxygen which is there outside, they are able to react with oxygen, but they are not going to react with water at all. For example, if you take phosphorus, you see phosphorus, when you see phosphorus, it immediately reacts with oxygen. Yes, that's why they'll store this phosphorus in the water. To stop the contact with oxygen, they'll store the phosphorus in water. So when phosphorus coming in contact with the atmospheric oxygen, it may catch fire also. So that's why to stop the connection with atmospheric oxygen, the phosphorus is stored in the water. So understood, children? Today we discussed about the reaction with the metals and non-metals, reaction with oxygen, how they are reacting. When metals react with oxygen, they are forming metal oxides. And the metal oxides are basic in nature. We had seen magnesium example, magnesium ribbon, when it burn outside, magnesium oxide is formed. That magnesium oxide we dipped in water and tested with red litmus. It was turned into blue litmus paper. So that shows that metal oxides are basic in nature. And one more example we studied about the rusting process. How the iron reacts with the water and oxygen and how the rust is formed. What is the property of that rust we understood. And how non-metals are reacting with oxygen we had seen with sulfur example. When sulfur reacts with oxygen, it forms sulfur dioxide. That means non-metals also reacting with oxygen and forming their oxides, non-metal oxides. But that non-metal oxides are acidic in nature. We also had seen the example of SO2 when mixed with water. It formed H2SO3, that is sulfurous acid. When tested with litmus paper, blue litmus turned into red color. That shows the H2SO3 showing acidic properties. And how metals are reacting with water also we understood. When metals, so like sodium, when it reacts with water, what is formed? Very vigorous reaction. The hydroxide, sodium hydroxide is formed along with releasing hydrogen gas and some energy. But all the metals are not reacting with water in same manner. When the metal is more reactive than hydrogen, then only they will react with the water. And non-metals will not show any reaction with water, even though they are reacting with oxygen, but they will never react with the water. That's why some non-metals are stored in the water like phosphorus. So understood, children? So these all the properties help us to identify metals and non-metals. And in coming class, we'll see the reactive series. Why some metals are more reactive than the other metals, we'll discuss in next class. So in today's class, you write an activity to identify how the metal oxides are showing base properties. So write that this is your home assignment. Write an activity. Write an activity to show that how metal oxides are basic in nature. Basic in nature. How metal oxides are showing base properties. We had seen 2-3 examples in our class. Any one example you take, and what are the materials you require to do that activity, and finally what you are going to observe through that activity. Clearly write and send me your pics, children. Thank you.